Have you ever looked at a machine and wondered, what exactly am I looking at? Is it a truck, a boat, maybe even a bridge? It sounds impossible, but one remarkable engineering machine is all three at once. It can drive across rough terrain like a heavy-duty vehicle, launch itself into the water, and then transform into a floating bridge capable of carrying massive loads across an entire river. Recently, videos of this incredible machine exploded across social media, leaving millions asking the same question. How is something this massive able to float? And perhaps even more surprising, how can several of these vehicles connect together to create a stable bridge strong enough for heavy equipment? The answers reveal some of the smartest engineering ever built. At first glance, the machine looks like an oversized military-style engineering vehicle. Its giant wheels and rugged body are designed to tackle terrain where ordinary trucks would quickly get stuck. Mud, rocks, flooded roads. It simply keeps moving, but everything changes the moment it reaches the water. Instead of stopping at the riverbank, the vehicle begins a carefully engineered transformation. Hydraulic systems unlock massive pontoons that have been folded neatly along both sides of the vehicle. Within moments, those pontoons swing outward and lock firmly into place. Suddenly, what was driving on land is now floating on water. And unlike older floating bridge systems, this machine doesn't just drift with the current. It becomes a fully powered watercraft, capable of navigating rivers under its own power. That's already impressive. But this is only the beginning. One vehicle alone can transport more than 500 people across the water. Yet engineers designed it with something much bigger in mind. When several of these units arrive at the same location, they don't simply float beside one another. They connect with remarkable precision, forming a giant floating bridge that stretches from one side of the river to the other. Within a short period of time, what was once an uncrossable obstacle becomes a roadway capable of supporting heavy vehicles. It almost feels like watching real-life transformers. Naturally, many people assume the biggest challenge is keeping all that steel from sinking. After all, steel is heavy. But here's the fascinating part. Whether something floats has very little to do with the material it's made from. Instead, everything comes down to one scientific idea discovered more than 2,000 years ago: Archimedes' principle. The concept is surprisingly simple. Any object placed in water pushes some of that water out of the way. If the weight of the displaced water becomes greater than the weight of the object itself, the object floats. That's exactly how enormous cargo ships weighing hundreds of thousands of tons stay on the surface. This engineering vehicle works on the very same principle. Those giant side pontoons aren't just empty metal shells. Inside them are multiple fully sealed compartments that dramatically increase the amount of water displaced. As soon as the pontoons unfold, they create enough buoyancy to support the vehicle's enormous weight. And engineers added another clever layer of protection. Instead of relying on one giant hollow chamber, the pontoons are divided into numerous independent sealed compartments. Why? Imagine one compartment becomes damaged by debris or a collision and begins filling with water. On many floating structures, that could create a dangerous imbalance. But here, the remaining sealed compartments continue providing buoyancy, allowing the vehicle to stay level and stable. It's a built-in backup system that dramatically improves safety and reliability during demanding operations. Of course, floating is only half the battle. The real challenge begins once you're actually on the water. Older pontoon bridge systems had a major weakness. They couldn't move by themselves. Instead, they depended on tugboats to tow each section into position. Everything had to be carefully anchored, coordinated, and assembled manually. That process could take valuable time, especially during emergencies when every minute matters. This modern system changes everything. Each individual bridge module includes its own propulsion system. Think of every section as having its own engine, steering system, and navigation controls. Instead of waiting to be pushed or pulled into place, every module drives itself across the water. Even more impressive, these systems can move forward, backward, and even make precise sideways adjustments. That level of control becomes essential when multiple modules must align perfectly with one another. Because building a bridge on moving water is far more complicated than connecting pieces on dry land. Currents constantly push against every floating section. Winds changes direction. Water levels rise and fall. Yet somehow, every module must line up within inches. The secret lies in electronically controlled steering systems that allow all the connected units to work together, almost like a single machine. Each movement is carefully coordinated. Tiny adjustments happen continuously until every section reaches its exact position. Only then does the next stage begin. Powerful mechanical locking systems engage automatically, pulling neighboring sections tightly together. This isn't a simple latch or a few chains holding everything in place. The connection points must survive enormous forces. Flowing water constantly pushes sideways against the bridge. Meanwhile, vehicles weighing dozens of tons drive directly across it. Every connector must resist twisting, bending, and shearing forces while keeping the bridge surface perfectly level. If even one section shifted significantly, the entire roadway could become unsafe. That's why every connection is engineered with extraordinary precision. Once locked together, the bridge behaves less like a collection of floating vehicles and more like one continuous structure. And that's where its true strength becomes obvious. This isn't just a floating platform, it's a temporary highway. With a rated load capacity of around 60 tons, the bridge is built to carry heavy engineering vehicles, rescue equipment, supply trucks, and other large machinery. Every major structural component, from the alloy deck frames to the locking pins, has been carefully optimized to distribute enormous loads safely. Drivers crossing the bridge experience a surprisingly stable surface that feels much closer to solid ground than most people would ever expect from something floating on water, which raises an obvious question. If engineers can build permanent bridges, why invest so much effort into creating one that floats? The answer comes down to one word: time. Permanent bridges take months, or often years, to design and construct. But disasters don't wait. Floods can wash away roads overnight. Earthquakes can destroy vital crossings in seconds. Landslides can isolate entire communities. When rescue teams need immediate access, waiting for permanent construction simply isn't an option. Engineers needed something different, not just another bridge, a bridge that could travel, a bridge with wheels, a bridge that could become a boat, a bridge that could appear exactly where it was needed, often within minutes of arriving. That's precisely what this remarkable system delivers. During normal times, these machines spend most of their lives quietly stored in engineering depots, rarely attracting public attention. They wait. Then, when roads disappear beneath floodwaters or rivers suddenly become barriers, they roll into action. They drive across damaged terrain, reach the shoreline, transform, navigate into position, connect together, and restore a vital transportation route when people need it most. Most bridges are fixed forever in one location. This one carries the bridge to wherever the problem exists. That's what makes it so extraordinary. Watching this engineering marvel in action completely changes the way you think about infrastructure. It's no longer just concrete and steel standing permanently over a river. Instead, it's a machine that adapts, transforms, and solves problems exactly when they're needed. In the end, this incredible vehicle isn't impressive simply because it can drive, float, or become a bridge. It's impressive because every bolt, every hydraulic system, every sealed compartment, and every locking mechanism was designed around one goal: restoring connections when the world has been cut apart. And perhaps that's the greatest achievement of all, because sometimes the most powerful bridge isn't the one built across a river, it's the one that can drive straight into it.